I did. I had Mickey Mouse slippers. I saw
Did you do the like the princess thing?
Now, we just did this problem, and we came out with an answer of -87.
my one.
Now you'll notice that the next problem says redo it. But it says redo it using the second row instead of the top row. Now, let's talk about that for a minute. So let's copy down the second row. Now, does anybody see anything that potentially could be a time saver? Okay, remember, what do we ultimately do with these numbers that we copied down? We ultimately multiply that. But wait a second, since it's a zero, there will be no point in evaluating that minor. Would you agree? Or this one. So basically, by choosing the second row, we are cutting our work in half, right? So the next time you see one of these, you are going to look at your determinant and you're going to pick the row that has the most zeros in it, okay? Now, let's go at any row. So, here's the part you can't forget though. Remember that whole same change thing? Okay, we got to do it again. But it always starts right here. Now I know I didn't copy down that number, but that's where I start my flip-flopping clock. So same, change, same, change, same. So again, this one's always the same. Same, change, I'm not going to worry about that because it's a zero. Same, change, the 2's going to become negative. Now, if I had used the bottom row, same, change, same, change, same, change, same. Down, over, same, change, okay? Now, let's go ahead and evaluate these minors. Remember now, it's the second row we've taken out. And that one is this one. So my minor determinant is 1, -3, 4, -2, -3, 1, and 0, 5, 6. All right, take out the row and the column. The row's already gone. Take out the column of the number that you are building the minor for. Now, with any luck at all, folks, we're going to get -87 again. So, moral of the story, find the row that has the most zeros. All right, everybody good with that? All right, now we're gonna find the numbers. This is a two-step process. The first step is find the determinant. All right, so think back, we just did a big determinant. How do we do these little ones? You can do these in your head. How do we do these little ones? Multiply, multiply, subtract. So this is gonna be -4 minus 6, -10. I'll just hang on to that number for a second. That's step one. Now, step two is, we're gonna build a new matrix. And it's kind of quirky how we do it, there's a reason for it, but it's easier just to remember what to do. When you build your new determinant, or your new matrix, go back to the original, and take these two numbers right here, see where my fingers are? And flip-flop them. So we're gonna put -4 and 1. And then see these two guys? You're gonna change their signs. So same change, the signs get changed. So that's gonna be a -3 and a -2. Don't move them, don't move them. These two physically get moved. These two get their signs changed. Now, take that new matrix, which is called the adjoint, by the way, that's the name of it. Take that new matrix and divide each of the numbers in it by the determinant. And then simplify, and that will be your inverse. So 2/5, 1/5, 3/10, -1/10. Could you, if this were a quiz question, could you check that answer? Would there be a way of checking that? What would you do? Multiply it by the original, and you better get the identity, right? If they're inverses. Can you think of why I like to find the determinant first? Would there be a reason, possibly, that it would be helpful to have the determinant first? What if the determinant works out to be 0? Then there can't be an inverse, because what do we do with the determinant? We divide by it. So anything you did after that point would be a waste of time. So I like to find the determinant. All right, one more. Then we'll go to our calculator. Oh, not quite. 2 more to do, and then we'll go to our calculator. All right, so first thing we do is find our determinant, and what is our determinant? 3. Now we're going to build our new matrix by taking these two numbers and flipping them. So 3 and 1. And then change the signs of these. Well, 0 is still 0, and then -5. And then we'll take each of these numbers in this new matrix and divide by the determinant. And then simplify anything that will simplify. So 1, -5/3, 0, and 1/3. Now, the next question says, okay, can we idea of inverses to solve a system of equations. And the answer is yes. Is this my preferred method? Absolutely not. If I find a system of equations in the hallway, I am not gonna do it this way, but we're gonna go through and learn how it works, okay? So, first thing we're gonna do is rewrite this system as a matrix equation. So my coefficients are 1, 1, 2, negative 3. My variables are x and y. And my constants are 7 and negative 6. So there is the matrix equation for that system. And to make sure that you're kind of really seeing how this works, remember when we multiply, we take row times column. So 1 times x plus 1 times y equals 7. See how that works? And then 2 times x minus 3 times y equals negative 6. So this is the same thing as the system, except I wrote it as a matrix equation. You've solved equations like this forever. Now they didn't look like that, they look like this. 2x equals 10. Coefficients times a variable equals a number. So what did you do to solve that? You had to get rid of this, right? Right? So you times it by a half or divided it by 2. So what if we took this system right here and we multiplied both sides by the inverse of this? Won't that cancel that part out? And it will leave me with xy equal to my answer. Now, the problem is, the inverse is gonna be a 2 by 2. And I can't just tack it on the end like this. Because this is a 2 by 1, and that's a 2 by 2, and that won't be allowed to multiply. So, Sammy, you're gonna like this. I gotta put it in the front. Or I can't do the problem. So I'm gonna multiply on the left side of both left sides of the equation. So the left side of this equation and the left side of this equation, I'm multiplying by my inverse. Okay, well, what's my inverse gonna be? You have to figure it out. What's your determinant? -5. And what's our new matrix gonna be? Switch them, so -3, 1. Change the signs, and then divide. So 3/5, 1/5, 2/5, -1/5. And that's what I'm gonna multiply both sides by my inverse. Now, what did we say was gonna happen right here when we multiply these, if these are inverses? They're gonna cancel out. They're gonna make the identity. So this is now gone. So I have xy equal to, and now I'm gonna multiply these two together. So row times column. So that's gonna be 21/5 minus 6/5. Did you get 15/5 or 3? 21/5 minus 6/5. And then this one's gonna be 14 plus 6. 20/5 or 4.
Wait, how did you get the inverse?
Okay, Okay, same way we did in our last two problems. I found the determinant. And then I flipped these two numbers, changed the sign on these, and divided by the determinant.
Why is it positive 3/5 and negative 1? And then the 2/5 and 1/5 are still. Oh, because they cancel?
Yeah.
Oh, okay.
Now, like I said, I don't like to do this way. This isn't efficient for me. But basically, I have a lot of writing up here, but basically, isn't this where the answer came from? So all you really need to do is take the inverse of the coefficients, multiply it times your constants, and that will give you your answer. If you wish to do the problem that way.
On like the quiz or test, are you gonna specifically ask us to use this method?
I haven't decided yet. I'm gonna talk it over with my partner. Okay? All right. Now, get your calculator out. We're gonna find the inverse of a 3/3. This can be done by hand, but I find it a big pain in the butt. So we're gonna do it on our calculator. 2x2s, you gotta be able to find the inverse of a 2x2 by hand. All right, so here we go. Have we done anything with our calculator yet? Okay, so you find a button called matrix. For me, it's a second right here. Some of the older calculators actually have a button called matrix. But see it, second matrix? Okay, so press second matrix. Now, like always, when you get into a new menu, a matrix menu, you got options across the top. Choose edit. So go over to edit and press enter. Because the first thing we have to do is put our numbers in. We're gonna put in matrix C, and we gotta get those numbers in. The numbers go in edit, okay? Now, first thing the calculator needs to know is, how many numbers are you gonna give me? In other words, how big is the matrix? Well, matrix C is a 3x3, so 3x3. Now, I've used my calculator before, so I already have numbers in here. It doesn't matter, just type on top of them, okay, if you have them. If you don't have any, great. And you just type them in. So 1, enter, 1, enter, 4, enter. -1, 3, 2, 0, 6, 7. As soon as you get the last one in, press enter, so it's set in there. Then we're done putting numbers in. So we're gonna second quit. Second quit. When we are finished with the edit menu, we have to get out, okay? Now we're gonna go back in, second matrix. I didn't call mine C, I called mine A. It doesn't matter, but A is my first one. I just press enter, and now I should see matrix A on my screen. You have an inverse button that actually is the matrix button. If you don't second it, X or -1, that's your inverse button, and press enter, and that's the inverse. Now, just for fun, those are decimals, they're not terrible, but let's do this. Press math button, math, and then enter, and it'll pull that thing up with fractions if you prefer to have fractions. Mine's too big for the screen, so I just use my arrow buttons and I can see the whole thing then. Okay, so second matrix, edit to get the numbers in, and then get out of there, second quit, and then second matrix, enter, puts up the matrix, and then -1 gives you the inverse. Okay? I wish you had a calculator. Okay. Yours does that, I just don't know how to do it. Okay. Last thing we're gonna learn today is how to solve a system using Kramer's rule. Wait. At the start of the chapter, we did substitution elimination. A few minutes ago, we did the inverse method. Now I'm doing yet another method. There are lots of ways to solve a system, and this is actually one of my favorite ways, and I'll show you why here in a second. First of all, to find the solution, which is going to be x comma y, it's a point, we're going to find the determinant of the coefficients. So 3, 2, 5, negative 5. We're going to figure out what that is. So go ahead, quickly figure out what that determinant is. 3, 2, 5, negative 5. Make sure they're lined up. What'd you get? Negative 25. You multiply, multiply, and subtract. That negative 25 is the denominator of your x and y. X and y are fractions, and the denominator of the fraction is negative 25. The numerators are other determinants, and it's real easy. When you set up your coefficients, this was the x column and this was the y column, right? And we've got these extra numbers that we haven't used yet. To find your x numerator, cut these out and paste them on top of the x's. So you're going to have 8, 9 to negative 5. To find your x numerator, cut these out and paste them on top of your x's. Guess how you're going to find your y numerator? You're going to cut those out and paste them here. Now evaluate those, and that's going to be, we're going to be done. So what is this one? Negative 58. And 27 minus 40, negative 13. I'm going to get rid of all the negatives because I don't need all those negatives in there. They cancel each other out. There's the answer to the question. Now, why do I like this method? Well, first of all, I can do everything in my head pretty much. But think, my normal favorite way is elimination. So think about if I eliminated the x's or something, and I got y equals 13/25. What's my next step after that? To plug it back in, and then I've got all this arithmetic with fractions. These are awful answers, but did I really have to do anything with them? No. Kramer's rule, that's the way it works. And I want you to think about this. It's so easy, but imagine being smart enough to figure that out. Some guy figured that out.